Rationalizing the denominator. Like I said, we did this in Unit 7. So when you do the problems that you see around the room today, they're going to be reviewing exponents, which I don't feel like we need to do since we just finished reviewing for your SOL test. But we haven't done a whole lot with rationalizing the denominator, so I want to cover that. Okay. So rationalizing the denominator simply means that you cannot leave a radical in the denominator when you're done solving your problem. So let's say we had something like 2 rad 3 over rad 6. So you have this radical in the denominator. You have to get rid of it. You get rid of it by multiplying by the radical that's in the denominator. So when you do that, when you times the radical times itself, it simply means you end up with just the radicand, which is 6. Because basically you're saying the square root of 36 is 6. Okay? So you really just end up with what's under the radical without the radical sign itself. And then you just perform what's at the top. Okay, there's like an invisible 1 here. So 2 times 1 is 2. And then you multiply the 2 rads together, you get 18. Now, you can do some reducing here, because you can also simplify 18. Okay. Is there a perfect square in 18?
Yes.
9, correct. All right. So 9 times 2 is 18. So either you can have your calculator do all of that for you, okay, but I'm not. So I'm just going to break this down to 9 and 2. So when I take the square root of 9 out, I get what? 3. You're going to multiply it by the number on the outside. So that's going to give you 6. And you leave the rad 2. Now, you can also simplify the numbers on the outside. So the 2 6s you see here, this one and this one, your final answer is just rad 2. Okay. So numbers on the outside can be reduced as well as numbers on the inside, right? So let's say you started off with something like, this would be example 2. And let's say we had 10 here and we had 6 here. Okay, let's just say we had that. Now, I could multiply by the rad 6. But you could also reduce all of this first, so you're dealing with smaller numbers. Okay? All right. So now I'm going to reduce 10 over 6, and you reduce it just like you ordinarily would with any fraction. So that's going to be 5 over what? 3. Okay? And the whole point of doing that is so you're not having to simplify, large radicands at the end. So if you simplify it first, you're dealing with smaller numbers. Okay, can you do it? Yes, you can. You'll just, again, be dealing with bigger numbers. So we're still going to rationalize the denominator because we have to get rid of that rad 3 in the denominator. So you just simply multiply by rad 3. So rad 3 times rad 3 is rad 9. The square root of rad 9 is 3. So like I said, you really just end up with what's under the radical. So at the top, I'm going to have 4 rad 15 divided by 3. Okay, now you cannot break the 15 down any further. So that is in simplest form, and you cannot reduce the 4/3. All right, last one on rationalizing, and then we're going to quickly review on adding and subtracting. All right, so this will be the last one. Let's do 3 rad 2 divided by rad 3. All right, so again, we're going to multiply, rationalize our denominator by multiplying top and bottom by rad 3, because that's like one whole when you do that. So you're not changing the value of the problem. So at the top, I'm going to end up with 3 rad 6 divided by 3. And of course, the 3's can cancel out because they're not under the radical. and you end up with rad 6 as your final answer. All right. Now, what if we are adding and subtracting? Okay, because we did this back in Unit 7 as well. So let's put a add and subtract. And you can only add or subtract if they have like radicands. All right, so, you know, this is going to be on your final exam. So that's why we're going back and reviewing some topics. So like radicand simply means the number under the radical. So if I had 2 rad 3 plus 5 rad 6 minus, let's say, 4 rad 3. So here you can only group the rad 3s together. You can't group with the rad 6 because that's a different radicand. Again, like radicands. So when you do that, you're going to take this one and this one, and you're going to just simply use the outside numbers. So 2 minus 4 is negative 2 rad 3, and you just bring down the 5 rad 6. Okay, you don't do anything with that. Now, can you reverse it? Yes, you can. You can write 5 rad 6 minus 2 rad 3. It doesn't matter the order. Okay, but again, you can only group them if they have the like radicands. You don't do anything with what's under here. You only add or subtract the outside numbers. All right. Okay, we're going to do one more. All right, now sometimes you might have to simplify the radical first. Let's say you had something like rad 45 plus 2 rad 5. So you can tell that 45 is not in its simplest form. It has a perfect square in it as a factor, which is 9. Okay, so you can actually break down the 45 to 9 times 5. Take the square root of 9 out, which is 3 rad 5. Bring down the plus 2 rad 5. Now they're like radicands. I can now add the outside numbers together, and that's going to give me what? 5 rad 5. That's it. Okay.